you are thinking at this point that what is the big deal about the electronic configuration of an atom, this is the answer for you. From the electronic configuration of an atom, we can predict the chemical properties of the atom. And one of the things we can easily decipher from the electronic configuration is the valence electrons in an atom. What are the valence electrons? The valence electrons are the electrons in the outermost energy level of an atom. That is the operative phrase in this definition. The electrons in the outermost energy level. And what is the use for valence electrons? The valence electrons in an atom are essentially the only electrons that participate in chemical reactions. Let us now look at the elements from the second row of the periodic table and use the electronic configuration of each of them to determine their valence electrons. Remember, the valence electrons are the electrons in the outermost energy level. So let us begin with lithium. The outermost energy level in lithium is energy level number 2. Lithium has 3 electrons. 2 of them are in energy level number 1, in the 1s orbital. Only 1 electron is in the energy level number 2. What that means is that the valence for lithium is 1. And that is why lithium will be found in group 1A in the periodic table. Let us take a look at beryllium. The outermost energy level in beryllium is energy level number 2. And beryllium has 2 electrons in that energy level, which means that the valence for beryllium is 2. And that is why beryllium is in group 2A of the periodic table. The outermost energy level in boron is also 2, but there are a total of 3 electrons in the outermost energy level of boron, which means that the valence of boron is 3, and you will find it in group 3A of the periodic table. Carbon has 4 electrons in the outermost energy level. That means the valence for carbon is 4, and it will be found in group 4A of the periodic table. Nitrogen has 5 electrons in its outermost energy level, which means its valence is 5, and it could be found in group 5A of the periodic table. Oxygen has 6 valence electrons, and that is why it is in group 6A. Fluorine has 7 valence electrons, and that is why it is found in group 7A. And lastly, neon has 8 valence electrons. That is why it will be found in group 8A. Using the valence electrons in the atom of each element, we can predict how the element will react in a chemical reaction. That is another way of saying that we can predict their charges when they form covalent compounds. Let us take a look at what I mean. The very first thing we want to understand is that the main group elements all want to be like a noble gas. Why do they want to be like a noble gas? Let us take a look at the two noble gases in the list that I have above. Helium has electronic configuration of 1s2. The n equals to 1 energy level can only accommodate a maximum of 2 electrons. And helium has those 2 electrons, which means that that energy level is completely filled and very stable. That is why helium would never accept any electron or be willing to give out any electron to any other element. Let us take a look at neon. Neon has 10 electrons. The valence electrons in neon are 8. The second energy level in any atom can only accommodate a maximum of 8 electrons, and neon already has those 8 electrons. So neon is unwilling to participate in any chemical reaction. That is why the noble gases are all stable, because they have optimal electronic configuration. And that is what all the main group elements also want to have. So the question is this: how will lithium react in a chemical reaction to be like a noble gas? There are two opportunities for lithium. Lithium can simply give out the 1 electron it has in its valence. And when it does that, it will be like helium. Or lithium could want to have 7 more electrons in energy level number 2. Now, gaining 7 more electrons is a tall order. That is why lithium will always react by giving up the only electron in its valence, so that anywhere you see lithium, it will have a charge of +1. Beryllium has 2 choices: give up the 2 electrons in the outermost energy level, or try to gain 6 more electrons to be like neon. The easiest one for nature to do, and the most energetically reasonable, is to give up the 2 electrons in the valence, and that means beryllium will have a charge of +2. Boron has 2 choices: give up the 3 electrons in the outermost energy level, or try to gain 5 electrons to be like neon. It will give up the 3 electrons, and it will be like helium, and it will carry a charge of +3. Carbon is at a crossroad. It has 4 electrons in its outermost energy level. So what should carbon do? Give up the 4 electrons or try to find 4 electrons from somewhere else? Carbon usually doesn't do either. It simply forms covalent bonds. We're going to learn about covalent bonds in the next videos. Nitrogen has a choice. Give up the 5 electrons in the outermost energy level or gain 3 electrons. The easiest one to do is to gain 3 electrons, and nitrogen will have a charge of -3. Oxygen has 2 choices. Gain 2 electrons to be like neon, or give up the 6 electrons in its outermost energy level. Oxygen will gain 2 electrons to be like neon so that it can be more stable. Fluorine has 2 choices. Give up the 7 valence electrons or gain 1 electron. Fluorine will gain 1 electron and carry a charge of -1.